Hello everyone, welcome to this next video in the series of Intro to Deep Learning. This video will be learning about loss functions. So as we all already know, a machine learning or a deep learning model learns through an iterative process of trying to adjust itself to best fit the physical given model. But how does it know what adjustments to make, where to make, and how much to adjust? It needs a guide, a mentor, to tell it, hey friend, you're off here and by this much. Can you make the necessary adjustments? So behold the loss functions. These are the functions that we calculate depending on the output of the model during each cycle. So what does this mean? Loss is a number, an indication of how bad the model actually predicted on a single example. That is, if the model is a perfect model and can predict with no error, then the loss will be zero. Else the loss will be higher. Hence the main goal of training the model is to get a set of weights and biases that minimize the loss so that we have a low loss on average across the entirety of the dataset. There are a variety of choices for loss functions to pick from, usually using the Python libraries and frameworks for deep learning. These provide a lot of options to pick from. And remember, the choice of loss function does affect the performance of the model. In this video, we'll be looking at two of the most important and most widely used loss functions, the mean squared error and the cross entropy or the log loss. Let's start with mean squared error. It's the average of the squared loss per example over the whole data set. Most of you might already know what a mean squared error is. And for the people who don't, it's just the mean of the square of the difference between predicted and the actual value of the output. This is the formula used to calculate the loss of the model using the mean squared error. And this is the pseudocode in Python to implement mean squared error. This is a function that takes in two parameters, the actual output values and the predicted output values that are predicted by the model. We initialize the sum of the squared as 0 and loop through all the outputs and the predicted values and find the squared differences and sum them up. And once we have the sum of all the squared errors into our sum square error variable, we then find the mean by dividing it by the length of the output array, which gives us the mean squared error. We can also use a built-in mean squared error function. Now, the next type of loss function is cross entropy or log loss. It's a stricter and more discriminating version of mean squared error. As the name suggests, loss is exponentially proportional to the error. That's the difference between the actual and the predicted values. The log loss gives a small loss if the difference is small, like 0.1 or around there, but is exponentially higher for the difference of around 0.9. And as usual, the log loss for a perfect model is 0 and is greater than 0 for not a perfect model. Cross entropy for binary or two-class prediction problem is actually calculated as the average of cross entropies across all examples. That is for the problem to identify if, like some of the examples for binary problems are like whether this is an image of a cat or not, or if this image of coin is facing heads or tails up. So this is the formula to implement binary log loss. Here n is the number of examples, y is the actual output, and p of y is the predicted value. This is the function that shows the trend of log function. It dramatically increases. So when you have a choice, the obvious question is what to choose. So when should you pick mean squared error and when should you pick cross entropy? Cross entropy is used for classification since it gives better results than MSE or mean squared error. But for classification problems, you almost always use mean squared error. So this is the Python code to implement cross entropy or log loss. It's similar to mean square error, just that the loss function is replaced with the log loss, that is the actual into log of the predicted. This function has been changed. Everything else is the same, as we initialize the sum to 0 and then loop through all the outputs and then find the mean of the sum at the end. All standard machine learning libraries have a built-in cross entropy function or a log loss function which can be used. So this pseudocode is just for understanding purposes. We'll most probably never be using this in our actual models. This is a pseudocode for implementing binary cross entropy in TensorFlow. So hope you guys now know what exactly are loss functions, why we need them, and how to implement them, and which one to implement when. So thank you.